Hello, good morning to all of you. I hope all of you are doing well. So in today's class, we are going to discuss about access specifiers. So access specifiers in C++ defines how the members of a class can be accessed. So there can be two types of members in a class. There can be data members and there can be member functions. So access specifier specifies the way how the data members and the member functions can be accessed in a class. Now in C++, there are three types of access specifiers, or there are three access specifiers, namely public, private, and protected. Now public access specifier, so whenever a member is placed with a public access specifier, then the member are accessible from outside the class. Now this is one of the important property of public access specifier. So whenever a member is placed with a public access specifier, the member are accessible from outside the class. The data member and the member function of a class declared as public are available for everyone, and other classes can also access them. So this is one of the important property of public access specifier. Now the public member of a class are accessible from everywhere in the program using the dot operator, that is called as direct memory access operator, along with the object of the same class. So what you can do is you can access public members of a class from anywhere in the program using the dot operator along with the object belonging to the same class. Now let us try to understand with the help of an example. So here what we have is we have a class rectangle, and here what I have done is I have placed the data members as well as the member function in the public domain of that particular class. So here public access specifier is associated with the width, height, as well as the area of member function. Now in the member function area, what we are doing is we are finding the product of width and height, and what we are doing is we are returning an integer value. So area is a member function that is declared as a function that takes in width and height and returns an integer value pertaining to the area of the rectangle. So here you see the data member as well as the member functions are public in nature. Now here what I have is I have defined my main function. So in the main function we have two variables, rect1 and rect2. Now since width and height are public members of the class rectangle, what we can do is we can access the public members through the object of the class, right? Okay, so rect1.width, rect1.height, rect2.width, rect2.height will not yield any error, because since width and height are public members of the class, so what we can do is we can use a dot operator or direct memory referencing operator in combination with the object of that particular class in order to assign values. So what I've done is I've assigned values to the individual data members of the individual objects. Then what I've done is I've invoked the function rect1.area and rect.toArea. So since it's public in nature, what we can do is we can use the dot operator to access the data members. So what it will find the product of 5 and 6 and 7 and 8 and display the results. So first statement will give me 5 6 are 30, and second statement will give me 7 8s are 56. So this is the way how the public specifier actually works. Now let us try to understand the private access specifier. So whenever members are placed with the private access specifier, member cannot be accessed from outside the class. Now this is a very important attribute of private access specifier. So members cannot be accessed from outside the class. Now the data member and the member function of a class declared as private are accessible only by the functions that are inside the class, right? So this is also important aspect that you need to remember. So whenever a member is placed in with the private access specifier, members cannot be accessed from outside the class, and the data member and the member function of the class declared as private are accessible only to the functions that are inside the class, and are restricted to be accessed directly by any object or the function outside the class. So there is a strict restriction that no object or function outside the class can access it. Now the private member the private data member of a class can be accessed using the member functions of the class or the friend function. So this is very much important statement that you need to remember. So private members are members that cannot be accessed outside the class, right? The data members and the member function of the class that is declared as private are accessible only by the functions that are inside the class. So there is strict restriction on the access of the data member and the member function by the function outside the class, right? And the private data members of the class can be accessed either using the member function of the class or the friend function. Now this is a very important statement that you need to remember. Now what I have done is I have modified the same program. Here what I have done is I placed the width and height. You see, I have placed the width and height in the private, because as I said, by default the access specifier, if it's not specified, will be private in nature. So here what I've done, I've placed the data members in the private domain of the class, and I've placed the member function in the public domain of the class. So here area function is public in nature, whereas width and height are private in nature. So now here what I have is I have the same program. So rectangle, so there are two objects, rect1 and rect2, are belonging to class rectangle, right? And width and height I've assigned. So width and height for rect1 I have assigned 5 and 6, and width and height of rect2 I have assigned 7 and 8, and I have invoked the function. Okay. And I've invoked the function here. So here what I've done is I've written rect1 area, so I've called rect1.area and I've called rect2.area. Now here, since width and height of rect1 and width and height of rect2 are private members, you see, listen to me carefully. So since here width and height of rect1 and width and height of rect2 are private members, so what you cannot do is we cannot access the private members. So this set of statements here will yield an error stating that private members are not accessible. So these members, the width and height of rect1 and width and height of rect2 are not accessible. So this particular problem or this particular program that you have will yield an error stating that the private member of the private member of the object cannot be accessed using the dot operator or the direct memory access operator. So this particular program will yield an error. Okay, so this is the way how the access specifier protects the access to the data member and the member function. So again, I'll say that in case of private, members cannot be accessed from outside the class. So if you want to access, then what you can do is we can make the function within the class access it. Right? So it cannot be accessed outside the class. So whenever we use dot operator in combination with the data members, it will yield error stating that the data members cannot be accessed since it is private in nature. Now let us try to move on to the next access specifier, that is called as protected. Now protected, whenever a member is placed in with the protected access specifier, member cannot be accessed from outside the class. However, they can be accessed in the inherited class. Now this is very much important statement that you need to remember. Whenever a member is placed with a protected access specifier, member cannot be accessed from outside the class. However, they can be accessed in the inherited class. Protected access specifier is similar to that of private access modifier or access specifier, that differs in that the class member declared as protected cannot be accessed outside the class, however are accessible by any derived class or subclass of the class. So here this is very much important. Now one of the properties of protected access specifier is that member cannot be accessed outside the class. That is very true, but however it can be accessed by the members of the inherited class or the derived class. So the major difference between the protected and the private access specifier is that in case of private access specifier, no one outside the class can access the data member and the member function, whereas in case of protected we have a little bit of liberty where the members of the derived class can access a member of the derived class can access the data member as well as the member function. So what I've done is I've taken a very simple example. So here what do we have is we have a class that is called a shape. In the class shape, right, what I have is I have public members. So here I have a function set with where with this assigned with the value of whatever integer value that you provided. And what I have is I have set height. Okay, set height function. So set height, here I'm passing an integer value, and height is assigned by the integer value that has been provided. So here what I have is I have the protected member, that is integer width and integer height, right? You see here again, I'll repeat it. I have a class shape. Okay, class shape, where in the class shape I have two member functions that are declared, that are there defined in the public domain, that is set width and set height, which initializes width and height, that is the protected member of the class, with the values that are provided to it, that is w and h. And width and height are placed in the protected domain of the class. So here width is protected as well as height is protected. Now what I'm doing is I'm deriving a class, right? Okay, so from class shape, you see, from class shape, this is the base class, right? From class shape, I am deriving a shape that is called a new class that is called as rectangle. So this is the way how what we can do is we can derive a class from an existing class. So shape is an existing class and rectangle is the new class. So what kind of derivation I'm having a public derivation. So now in that particular class, what I have is I have a function that is called as getArea, that will return the product of width and height. Now just see, width and height was the protected member in the base class. Now as I've said, in case of protected access specifier, if the members are provided with protected access specifiers, and the members of the class can access it and the members of the derived class can access it. So here rectangle is a derived class. So what I can do is I can have a function that is member function in the derived class that can access the protected member of the base class. So width and height are the protected members of the base class. So here what we can do is we can have a function that can access width and height of the base class. So here class rectangle is a derived class of shape class, that is the base class. We have a public derivation. So this is a very simple way of deriving a new class, right? Again, so now I have declared an object rect of type rectangle, where rectangle is a derived class of shape. So rect dot set width. So what I can now do is I can access the set width of the base class, because the derived class can access the members of the base class. So set width. So set width is the function that is there in the base class, because the derived class derives the property of the base class as well. So set width and set height are the two derived properties of the base class. So rect is an object of type rectangle, where rectangle is a derived class from shape. So whenever it is publicly deriving the behavior, so it derives the properties of the base class as well. So set width and set height are the two properties that it has derived from the base class. So it can make use of that. So what it will do, it will set the width and height of the the object belonging to rect, that is belonging to rectangle class, which further belongs to shape, which is derived from shape. So here it will set the protected member, that is width and height, with values 5 and 7, right? So once the value of the width and height has been set to 5 and 7, now what I can do is I can call the member function of the rectangle class itself that finds the product of width and height. So here it will give me 5 into 7, that is 35. So this is the way how protected member can be accessed. So again, I'll repeat it. In this particular program, what we have is we have a base class called a shape. In the base class, we have two member functions, set width and set height, defined in the public domain, which takes an integer value and which assigns the integer value to the member data members, that is width and height. So width and height are two data members that are placed in the public domain, that are placed in the protected domain of the class. So protected members can be accessed by either the members of the class or the members of the derived class. So now here just see what I've done is I've derived a class called as rectangle from the base class shape, and what I have is I have a public derivation. So here in the class rectangle. Now what I have is I have a member function that is called as getArea, which returns the product of width and height. Now it has inherited the behaviors from the base class as well. So what are the inherited behaviors? The inherited behaviors are set width, set height, and the protected members width and height. So in addition to the inherited behavior, it has its own additional behavior, that is getArea. So now what I've done is I've declared an object rectangle rect from of the class rectangle, where rectangle is derived from shape. So now rect has altogether it has five properties of its own. So two are data members, that is width and height, and three are member function, that is get width, get height, and set width, set height, and getArea. So what it can do is it can use the behaviors to set the value. So set width and set height will assign 5 and 7 to the protected member, that is width and height. So it will assign 5 and 7 to the protected member, that is width and height. And then what I have done is I have determined the area of the rectangle using the getArea. So it will find the product of 5 and 7, that is 35. So this is the way how protected access specifier actually works. So the major difference between private and protected access specifier is that protected in case of protected access specifier, the class and the members of the class and the members of the inherited class can access it, right? Okay. Whereas in case of private, no other members outside the class can access it. So that is the major difference between protected and private access specifier. So now let us try to summarize. Okay. So we have access. We have classes, same class, derived class, and outside class. We have public, private, protected, and private. So same class. Yes, public members can be accessed, protected members can be accessed, private members can be accessed. So the members of the same class, the member function of the same class can access public member, protected member, private member, right? So the members of the same class can access all the three types of members, right? The members of the derived class, yes, it can access the public members. It can access the protected members, but it cannot access the private members. So this is very much important. Outside the class, only the public members can be accessed. Protected cannot be accessed, as well as private cannot be accessed. Now just see, again I'll repeat it. So the members of the same class can access the public member, protected member, and private member. Members of the derived class can access public member, protected member, but it cannot access the private member. Members from outside the class can access the public member but cannot access the protected and the private member. So this is the logic behind the access specifiers. So in today's class, what we have learned about is we have learned about what is an access specifier. We have learned about public access specifier. We have learned about private access specifier. We have learned about protected access specifier. We have learned about the differences between the public, protected, and the private access specifier, and we have tried to understand it with the help of examples. And then what we have done is we have created a summary of different types of access that can be provided by different access specifiers. So this is very much important, so you need to remember it. So good morning to all of you. Thank you very much.